So I was somehow fascinated with the way these large language models can understand language. And I was somehow at the same time put off by the hallucination problems. But there is, before the language models start to generate text, they have this internal representation of language and their input that is really impressive. And I wanted to somehow profit of that and mobilize that a bit. So I wanted to play around a bit with it. And that's the project that came out of it is what I'm going to present to you today. Maybe, let me just put the link to the slides in the chat. So here we are, and back. So I want to say a bit about what I mean by embeddings today, and then present kind of the back end of or the API for an embeddings store that I have been developing, and then the experiments that I'm now that it's running since a few days only, but I have started to implement some experiments in our digital scholarly edition or in a test platform of it. And then get back to the question of what is it in terms of the API that is interesting for scholarly editor or digital editorics, more generally speaking. So to begin with the question, what are embeddings? That's kind of one of the internal data objects of those large language models. So we have these large pre-trained language models that have a new mechanism of coping with massive amounts of training data, and they manage to somehow detect features in the input that are relevant to the task that they are supposed to solve. But with the training data growing, and also with the number of like parameters inside these neural networks growing, they develop like this capability of transfer learning. So they understand a bit more than what they are actually supposed to solve. So they learn to understand language even before knowing what it is useful for. And then they somehow develop this capability of understanding a text that is being submitted to them and operate on them. Unfortunately, those large language models that follow the chat paradigm, they somehow detach themselves a bit from the input text and start producing text from the top of their heads, so to say. And then one keeps one's fingers crossed that it has some relation to the task that one has asked them to solve or to the input text that one has given to them. But anyway, the understanding or the ingestion of the input text, that's a common task in many of these models. And that's also something where you can somehow capture the result of this ingestion process and export it, so to say, and in this sense have a data object that represents the internal understanding of the language model of what the input text meant. And as I was saying, this is an impressively good understanding in many cases. There are two interesting aspects that are relevant to, in my case, scholarly research or scholarly use of these things. One is that these objects and internal representations can be processed so that you can calculate how similar or how distant one data object is from another one. That's this old example from the Word2Vec program from, I don't know, a couple of years ago, with the king and the queen. I don't know if maybe we can talk about it afterwards. But the second idea is, if you have a language model that has been trained on multilingual input data, then it can understand and translate the information. And these models have an internal representation of concepts that are somewhat independent of the input, of the words they find in the input text. These kind of capabilities are materialized, so to say, in the embeddings. So an embedding then is for some input text, the language model produces a long sequence of numbers representing its own internal conceptualization or representation of the input text. And the different providers, commercial or free, LLM service providers, they have their embedding services. OpenAI, that's the best known one. They have two very capable embedding models. Then there's a free one that is also from Cohere, that is also free for scholarly use and also multilingual. And I have yet to make some experiments to find out where one is more powerful than the other one. And with Ollama, you can actually host your own language model. Like if you have these language models like Llama or Falcon or some other ones that are freely available, but you have to have a service or that is hosted somewhere. But with Ollama, you can host them on your own infrastructure. Now, what is it that I want to? So the idea is I want to work with those representations from or those representations of our own texts, and I wanted to have a way to interact with an embeddings service or with an embeddings storage from our own digital editorics platform. So I was thinking I could develop an API that would be an interface to a vector database backend. So the interesting thing about vector databases and PostgreSQL, that's a very well-known and established database that has a vector or embeddings extension. And with this extension, it can calculate, for example, these similarities very, very quickly. So you have an object that is represented by, I don't know, 3,000 floating point numbers, and you have another object that is represented by another series of 3,000 floating point numbers, and you want to know how similar are those two 3,000 number sequences to one another. And this backend can calculate this very quickly. But it has an SQL interface, and I wanted to have a REST API. I wanted to interact with it with JSON objects. I wanted to have user and project management and rights management, and so on. So I started developing something like a middleware with which I could store my embeddings in this database, and then also retrieve the embeddings that I stored there for the purposes of the digital scholarly edition. You would, for example, have calls that would get information about the users of the vector database, the projects, but then more importantly, you would post your embeddings to a project here, to John Doe's or Jane Doe's FUBA project, and you could get them, and you could get the similars for a certain text ID of that project. So if you send a GET request to the host where this was running, to this embeddings endpoint, specifying the user and the project that I created for our Salamanca edition, and then the text ID, then you would get a JSON response like this. Here's the text ID is repeated. That's actually a URL. Could be a DTS identifier, for example. In our case, we have, for historical reasons, so to say, we have our own URI identifiers, and they have to be URL encoded because they are here on the path, and browsers and infrastructures don't like if there are forward slashes and columns in the path parameters. You have information about the project and the user. You have information about what large language model service these embeddings are related to. There's the text itself, the plain text that I had extracted before, and here is a row of, or a vector of 1,500 of these numbers. That's the representation of the text. And then we have some metadata. That's actually arbitrary. You can put any metadata in there. And I want to provide a way to have it schema checked, but at the moment you can put anything there. I forgot to put the title of the text in there, but you have the author and the year when this text was published, and here is the URI again, only this time it's not URL encoded, and you have even the language. So this is kind of one, the embeddings for one paragraph, 1,500 of these numbers and some metadata for this paragraph. And I have stored 70-something thousand paragraphs in the database, which made me capable of doing something like this. Here, this is our normal reading view of one of the texts, and then we have, for the different paragraphs and sections, we have these context menus, and here is a new one. Open the embeddings experiment for this paragraph. Unfortunately, okay, so you see that there have been two similar texts to this one found, and now what it is doing now, it has somehow downloaded the plain text from the vector store and sent the two texts to OpenAI, the chat API, and asked it to discuss whether the two texts are similar or not. So there should be a comparison here, similarities and differences, and so on. the idea is, no, I'm sorry. I skipped what I wanted to say. What I wanted to show actually was not the digital scholarly edition yet, but the API. Maybe it was worthwhile having a glimpse at the scholarly edition so you know what this backend communication is good for. But that's what I actually wanted to show. So here, I hope this is readable. We have the different users. I can say as an admin, I'm authenticated by a token. And if I send it to the users, a GET request to the user endpoint, then I get a list of all the users. If I send a request to this particular user's identifier, then I will have the user handle, the name, email, and so on. And that's the hash of the key that was handed out to this user when the user was created. And also the user, him or herself, can have the same information, but any other, I don't have this, any other user who does not authenticate themselves with the right token will not be able to see this. And that's more or less the same with the projects and with the embeddings. So here I can get information at the project's endpoint for this user and this project name. I get the information with a description. Here I can see that there are 75,000 paragraphs with their embeddings stored. And there's Sal, that's the user, that's the owner. There could be more authorized readers that would also be able to read the embeddings here. Here, that's the one that was shown on the slide. Here's the vector. If I get this, or here I can see there's a different project that I have created for this user with another language model provider, but I haven't used that at the moment. And again, here there's the similar. That's the interesting endpoint, the similars endpoint. Here, this is the full address, the internet address. The similars endpoint. The user is Sal. I'm afraid I cannot increase the font size. I hope one can read it. Then comes the project name, and then comes the identifier for which the similar vectors should be looked up. And then I can have a threshold for the similarity and a limit how many items I want to have at maximum. And then we will see that there are 5 for this paragraph. There are 5 separate 5 other paragraphs that have a similarity that is beyond a certain threshold. Now to the actual platform, the digital collection of sources. Yeah, I remembered that I was somehow getting ahead of myself, because I realized before I wanted to show you the actual workings, I wanted to say a few words about the project, and I'm going to do this now. The School of Salamanca is kind of an an academic school of jurists and theologians and other humanities scholars of the 16th and 17th centuries in Spain, but also in this from the University of Salamanca. But then they also got posts in Lima and Mexico and even in the Philippines. So the whole Iberian Empire was somehow, or the universities of the Iberian Empire were populated by scholars, priests, confessors, and even legal advisors that had been educated at this school and that also would contribute, we would say, to the development of the school and to the development of Western political thought. The problem is that no one really knows why this is a school and who belongs to it and on what grounds do we say about one person he belongs to the school and the other person maybe not. And this is something that the research on this is something that the project is meant to facilitate. This is why we establish a digital collection of sources of more than 100 works spanning almost 200 years. And we're in the process of establishing TI transcriptions and editions of those works. Anyway, the second pillar of the project is a dictionary. We have 150 words like contract, authority, Indians, or equity, or others, war also, for example, where these authors have been very active in debates, also criticizing the Conquista and discussing, okay, on what grounds could something like this be justified? If it can be justified at all, then on what grounds would this have to be justified? So there was a theological, ethical, and juridical discourse on the developments, the substantive developments in the 16th and 17th century. And we invited authors from the legal studies, from theology, from philosophy, and history to write articles on how these authors have somehow shaped and influenced the discourse on contract, for instance. And soon the question arose, given that we have this huge amount of text, we do have a full text search, obviously, on our web platform, but are there additional ways in which we could support our authors in writing on these things? So normally the authors would go to the website and search for contract, for example, and then find all paragraphs where the word contractus appears. But maybe we could do more. So what I have done is I have extracted the plain text from all the paragraphs and run them through an embedding service. This is not automatically. I have kind of a Jupyter notebook which does that and uploads the results to this vector database that I have shown. And then I have added some retrieval augmented generation function to our edition platform, like the one that I have shown, and I want to do some more work on the search page, for example. So the idea was, now that I have these embeddings and can calculate with the distances between the paragraphs, I want to find similar paragraphs based on the meaning of the paragraph rather than the presence or not of some particular word. And then if I have the paragraphs that are similar in their meaning, maybe then some chat bot can explain or can assess whether the authors disagree on certain points or whether they are talking about the same thing or not. So that's when I wanted to show the digital edition. So here's our context menu, and here is the new comparison tool. And in the back, behind the curtain, so to say, this paragraph or the vector store is queried with the ID of this source or original paragraph. And then the vector store says, yeah, here's another, in this case, here's a second paragraph, which is similar enough that it might be worthwhile having a look at. So this is para raíces de las preguntas. That's our paragraph here. And then there's another one. There's a longer one. Now I'm waiting again. Could use some caching also, but I'm not there yet. Here's the second paragraph, and I haven't read them now. For some reason, the vector store or the embeddings are similar enough that the vector store says, here's a candidate. And then that's what ChatGPT says. Both texts are concerned with legal and ethical considerations surrounding the concepts of theft and restitution. And then text 1 and text 2, if I had thought to put the text's titles in the metadata, then it would also be able to talk about the texts, not with those numbers, but with the actual title, probably. And then we have similarities. Both texts discuss the role of consent, and so on. And here we have the differences and some conclusions. And if I go to another paragraph, now we have 6 similar texts, and now probably ChatGPT will be taking a bit longer to analyze them and find agreements and disagreements, but in the end it will be there. This is where I'm at the moment, and it's again only texts by the same author. I also had some paragraphs where paragraphs from different authors had been suggested. Anyway, this is where I'm at now, and I want to have some work on the search page too, because here I have, let's see, here I have a list of texts. So in 31 works, there are so and so many results, and each of them has an embedding, and one can see, maybe one can cluster them and see, okay, so and so many paragraphs in the search results, they are very similar, but they are dissimilar to a second set of results. This is something that I wanted to have here, but it's not finished yet. So back to my plans, and in my invitation to discuss whether this is something that is interesting for digital scholarly edition platforms like TI Publisher in general, or if it's a particular or a special need depending or particular to our own Salamanca project. These are rather well-established features for that you would expect an API for a passage to deliver. You get for a passage, you get the plain text, you would get XML and a citation recommendation and so on. Actually, you would also, in some way, you could get an HTML representation, or maybe even an ebook. That's all nothing to do with embeddings and so on. But here's also what aren't these also interesting features to have in an API for a passage. Send this paragraph to an embeddings database. I'm not sure if this is really something that you would want to do, like clicking on the paragraph or something, or harvesting the paragraphs in with a harvester. I don't know how to trigger, how the scenario would be, how this would be triggered. But anyway, sending this to an embedding service or to an embeddings database, that's one idea. Then get the embeddings. We already have this at this, I'm sorry, here. This is actually what we have, the API where I enter the text ID and I get the embedding. Only this is a different server from the platform. It could be an idea to have a redirection or something like that. Also get information about the most similar passages from the corpus. That is what we had on this other server at the similars endpoint. But maybe not just the IDs of the similar passages, but we also can deliver the metadata that the vector store has stored. Or we could provide a translation. That's also a possibility for an API for a passage, and then maybe get the similar or calculate the similar passages based on the translation, so that there's no bias towards sources that happen to be in the language that the original text was in, but that it's more language neutral, maybe. And then this is where I was and where I'm currently working, namely API for collections of passages, like search results or bookmarked passages, which we do not have, but one could think about these things. We could also send whole collections of passages to embeddings services or databases, obviously. We could download passages as a subcorpus. That would be interesting, I guess. But we could also find documents that are similar, like we did with the individual documents, especially if, and it's especially interesting if they are similar, but for some reason not included in the set. So we have a set and they have kind of a certain cluster in the space of embeddings. And if there are a couple of more documents right in that relevant embedding space, it would be interesting to see why they did not appear in the set in the first place, for example. Or we could visualize the distribution of those paragraphs in the embedding space and maybe do some clustering or do an ad hoc topic modeling. Like, say, we have these 3 clusters. Now let's look into them and see what the documents in this cluster are about. There's a mechanism or a software library called BirdTopic that does something like that. I'm not sure if this is something that works quickly enough to make any sense, or at least in the scenarios that I'm thinking of currently. But maybe it's worthwhile to consider this. And then you could always have more summarization, like explain the consensus in more detail, or link like these scholarly search engines like Elicit and Cite and so on, link them to their respective sources that they refer to. That was it. Hopefully it was somehow a good middle ground of technical and non-technical and conceptual presentation. I'm looking forward to what you think of it in technical and concrete terms, but even more so in general terms, how this fits to your ideas and if you see something in it for you. Thank you.